6. Find K. There it is. Yep. Okay. So this is an X value, that's a Y value. They have to fit with this equation. We can just substitute them in. Sub this point right into equation. You can rearrange the equation if you like, but you don't need to. I don't think it's going to add anything. So anytime I see a X, I'm going to write a 3. Anytime I see a Y, I can make it a K. Minus 6, well that's 6x, x is 3, plus 16y, but y is k. And then I've got minus 8, and it equals 0. So that's a number, that's a 9, that's a k squared, that's a minus 18, that's a 16k, that's a minus 8. So 9 minus 8 is 1, 1 minus 18, that's 17. So minus 17. And I've got a k squared. I've also got a 16k. I can factorize this, use null factor law to solve. Product and sum, right? Remember this? Product and sum. Hopefully you're good at this. You don't need to do this working necessarily. So I need numbers that will give me that 17 when I multiply. 17 and 1, it's a prime number, so it has to be that. Can I build the 16 out of it? Yes, I can. So I need to sum to 16. Therefore, k minus 1, k plus 17 equals 0. Null factor law says that's got to be 0, so k has to be 1. Or this has got to be 0. How do I do that? K has to be minus 17. Find k. We've done it. All right. It should make sense to you that there's two solutions. Circle. Center would be at 3. Half that, put a minus on it, and minus 8. 3 minus 8. Why do we have 2 points? We've got a line through x is 3. We've got a point, there's like a point there and there's a point there. You could think about it. Imagine an x equals 3 line going through the graph. And up here, 3, 1. Now, you obviously don't have to draw this picture. I'm just trying to explain, do a bit of extra explanation in the video, right? Okay, I think that's enough for that one. That was worth 4 marks. All right, using technology or otherwise, find the point. Using technology can be a bit tricky if you've got a circle. You could rearrange though. Y equals, well, let's keep it as a squared first. 18 minus x minus 2 squared. We are trying to encourage the use of technology, but for graphing on your graphics calculator, unless you go to parametric equations, which is a little bit complicated, you've got to enter everything as a y equals. You'd have to enter it twice, plus or minus square root. I mean, you can do it fine. The graph doesn't look fantastic, but it's worth 5 marks. So, but it's telling you can use technology, so yeah. Normally, if you can use technology, you don't get so many marks, but anyway. I'm going to do it without technology. Find the point of intersection between a straight line. All right, using the straight line, maybe I'll call that equation 1. Equation 1 could be rewritten as y equals minus 4 minus x, or maybe minus x minus 4. Right, and then I call this equation 2, sub 1 into 2. We don't have a lot of space here, but I'm trying to explain to the reader of my test what I'm doing here. So anytime I saw y, I'm going to make it this, minus x minus 4. It starts off, equation 2 starts off with x minus 2 all squared, but then we've got our plus y squared. Plus y squared, I mean, we could write it x plus 4. Maybe put it in like that, or we could just leave it like, we'll just leave it in this form. We've got a plus minus x minus 4. When you square this, you're going to get positives everywhere. Equals 18. Maybe we do minus 18 equals 0. Because we may have two solutions. When you've got a line and a circle, here's your options. There, two solutions, or it's a tangent. So it's hard to draw, sorry. Single point, or the line misses the circle altogether, no solutions. We'll find out if we get two solutions or one solution. Presumably there is at least one solution. And if I set up a quadratic equal to 0, that makes it easy to solve. Right, so these are perfect squares. Now in here we might just go a bit slower. We'd have minus x times minus x, x squared. Your 2ab term, you've got that times that makes 4x, you double it. Then you've got this squared plus 16. And you've got a minus 18. Let's tidy it up. We've got a 2x squared minus 4x plus 8. That makes plus 4x. Then you've got a 4, 16. That makes 20 minus 2 equals 0. We can divide everything by 2 because it's all even numbers. X squared plus 2x minus 1. Why am I doing minus 1? It's plus, isn't it? 420, 20 minus 18, that's plus 2, sorry. So that's a plus 2, that's a plus 1, it equals 0. This is a perfect square, hopefully you're picking it up. To spot the perfect squares, you should be looking for, is that squared and is that squared? Maybe it's a perfect square. If this is 2ab, right, a equals x, b equals 1, ab would equal 1x, 2ab equals 2x, right? So if it matches up, you have a perfect square. And in that instance, we could write this, and this means there's only one solution, only one way to make this 0, if x is minus 1. All right, now let's see if we can solve it using technology. We'll just write down what's the y. Y equals minus x minus 4. That's the straight line equation. Get rid of this. Hopefully it won't clutter the calculator view too much. Calculator, calculator. Oh, that's right. I was going to show you that in the last video, and then I forgot. Your calculator, don't use it very much. In apps, you can draw ellipses. It's in Conics. And I was going to show you how, if you've got an equation in that form, It's an ellipse, not a circle. Right? Because that question was a little bit odd. Wasn't expecting that one to come up in the test. Anywho, we've moved on from there. I've got some other stuff in here. Let's get rid of that. Press clear. I got x equals minus 1. This is going downhill. It's cutting through at minus 4. Pretty sure it's going to intersect at the minus part, but I suppose we put them both in. So I think you could probably get away with just putting in the minus square root for your circle. But let's say you weren't sure. You're in a test, you want to be extra careful, so you're going to try and graph as much of the circle as you can. And I say that because the calculator doesn't seem to join up these surds very nicely. So this is the plus square root 18 minus brackets x minus 2 all squared. Right, so that's my circle done, and then I had a straight line, y equals minus x minus 4. Now viewing window, well, let's just try a standard, see what happens. Yeah, it's tangential. See, this I'm not sure why it won't join up the surds. Right, I only got one solution. It was at x equals minus 1. Now, it looks like an ellipse. It's not. If you want to see it as a circle, do zoom square. It's just because you've got this widescreen view, if you will. And the screen's a bit tiny. Now, if you try and do an intersect, I don't think it will work. First curve, yeah, blue. Second curve, no. I want black. How do I get? Yeah, that one. I think tangents may not work. Let's find out. It's up here. That's, I'm guessing up there, minus 1. Alright, found it. Yeah. It's a bit worried it wouldn't count that as an intersection, but it did. So x is minus 1. There's the solution. Y is minus 3. I wish it would give you whole numbers, but you can, I'm sure you could figure out that that's supposed to be a minus 1 and that's supposed to be a minus 3 if you round it up. Alternatively, second calc, put in a value for x, because we found one, minus 1, press enter, and you can see it's locking onto that point. I mean, you could maybe zoom in a bit if you wanted, adjust your viewing window. Kind of like having it in the square view though. Now we'll just leave it at that. All right. And let's move on. Okay. Hyperbola questions. All right. Oh, hang on, I didn't fully answer the question. Comment on the geometric significance. Right. The line is a tangent. Right. The line is a tangent. Maybe there's the extra mark there as well. To the circle. Right, so comment, read questions carefully. I almost didn't finish answering that properly. In the test, there's a mark gone. Right. Okay. Question 8, consider the graphs. What transformation maps A onto B? So it's like that's our starting point, A. Something's happened to get to B. Now here, it's moved 2 to the right. And here, it's moved 5 units up. So in your booklets, they talk about that. We've done this in class. The way you could describe it, there is a horizontal translation is the word we use for moving left and right, up and down. So it's a translation, that's a type of transformation, as opposed to a reflection or a different kind. So it's a horizontal translation 2 units to the right, and it's a vertical translation. I think there's a shorthand way that the book writes about this, but I think this answer here is showing good understanding, and you know, I would answer it that way. Okay, sketch it. Right, time to get a bit sketchy. Sketch. I've got to remember what the equation is. 6 x minus 2 plus a 5. Alright, so that's what I'm working with. Y equals 6 on x minus 2 plus 5. So nice and big. Again, apologies because I cannot draw straight lines very well. Gee, I tell a lie. I do have a straight line tool, don't I? Maybe give it a go. I tell a lie. I'm going to put the x-axis down low. Did that work? Yeah, that's way better. Why haven't I been using that? All right. The reason I've put the x-axis down low is because I know that there's a horizontal asymptote at y equals 5. 1, 2, 3, 4, 5. All right, so I'm just putting that in now. Notice I'm doing this before I try and draw the hyperbola. I think it makes it a lot easier. Notice that I'm about to label this. Right, this is 5 marks. Right, there's a mark. You must draw your axis. You must label your axis. You must label your asymptotes. You should not be losing marks. You should be getting marks. Right, especially when they're easy to get like this. That 2 is moving at 2 units to the right. X equals 2. I can sketch my hyperbola. I notice here it's going to cross the y-axis. It's going to cross the x-axis. I will do this with technology in a minute, but let's just have an x-intercept. That's happening when y equals 0. So that will happen when 6 on x minus 2, plus 5 equals 0, or when 6 on x minus 2 equals minus 5, or when 6 equals minus 5x, we'll have minus 2 minus 5 plus 10, take it over there, we get minus 5x is minus 4, x equals 4/5, so it's coming through about here, and I think that's a nice point to indicate. Right, so x is 4/5. You can probably get away with just writing 4/5, but I'll write it properly as an actual coordinate, a point. Now the y-intercept, easier to work out, I think. The y-intercept is when x is 0. So I'm working out the y-intercept. Happens when you get 6 on minus 2, because that x is gone, it's a 0, plus 5. And let's just write, it's a y value, so it's a y equals, we have minus 3 plus 5. 6 divided minus 2, that's minus 3. So y equals 2, it's here, and that's maybe helping me. My curve's got to come. Oh, not easy with this pen. Like that. This one should be, there should be a symmetry with this. So try and sort of make them the same shape. But notice I'm not putting a scale here on my x and y axes. So, it's just a sketch. I don't have to be too worried. Oh, I forgot to label the y-intercept. The y-intercept, x is 0, y is 2. That's the point there. So I like to label intercepts. I think some teachers might say, you know, pick a point and label it. But I would certainly give this full marks, although I'd like to see this axis drawn a bit better. Reminds me you should be bringing a ruler to the test, I think. Now, if I can remember that equation, I just want to remind you again that we could be graphing it. Just maybe deselect these so they won't graph. The reason I might want to graph it in particular is it's going to make it quicker and easier to see those axis intercepts. It was a +5, wasn't it? So it's y on x minus 2 +5. Maybe just do a zoom standard. There it is. You know, I might want to adjust the window a bit there. Give it a bit more y max. Whatevs. If I wanted to find those values there, let's have a look. A 0, right, that means when is the y 0? Left bound, right bound, whoa, that'll do. And our guess, somewhere in the middle, there it is, right there. 0.8, that's the same as 4/5, okay? If I want to find the y-intercept, there isn't a y-intercept in the TIs, but there's this value. So when the x equals 0, click, there it is, right? Y equals 2. I think it's a good idea to label axis intercepts when you're getting 5 marks for a sketch. Make sure you get all those marks. Number 9, find where the line meets the hyperbola. I would can't see another way to do it. The line equation, rearrange it. Oh, I can see another way to do it, to be honest. You can graph them again, right? If you're graphing, you'll have to rearrange anyway. So y, now I'm going to divide everything by 2, so I've got a single y. That x we have to add to both sides, then we have to divide it by 2. The 12, that can stay where it is, but it has to be divided by 2. So there's my line. Notice I've got y equals there and y equals there, right? So those are the same. At the point where they meet, those two numbers for y will be the same, right? It's meeting at a particular x and y point. And at that point, both equations give the same y value. Both equations have to use the same x value, right? Therefore, you could say half x plus 16 needs to equal minus 10 on x. I don't like this half x. I'm going to go through and times everything by 2, although I guess that's optional now. I've done another silly mistake. When I went to half 12, I said it was 16 instead of 6. Apologies. That's really where in a test, you know, this is where you can lose your marks. Silly mistakes. So if you do have time in a test, go through and check. Now the best way to check a test is to actually cover up what you've done, or at least try not to look at it and redo the test, right? Now this is a technique that you might not be used to. Because x is just some number here, we can times everything by x nicely. That will become minus 20 there. I'm going to move it over, make the equation equal to 0 so it's easy to solve. Factorizing product and sum. right? What two numbers multiply to give it 20? What two numbers also, when I do FOIL here, 2x, 10x, and they sum up to give the 12 equals 0. Therefore, x has to equal -2 or -10. Now, I think it says find where. I think you should always be saying the actual point. So the curves meet at -2. Now if I put the -2, this equation will be a nice and easy way to do it. Y equals -10, where x is -2. -10 divided -2 is a 5. They also meet where the x is -10. -10 divided -10 is a 1, and that was -10 in the x. Really is getting a bit tired. Okay, graphing this, we've got a line, the gradient's not that pronounced. You'd be wanting to do this on your calculator, right? The hyperbola, normally they look like this, but all the y's have become negative, so you're looking at a hyperbola like that now. You've got a straight line coming through at 6, fairly low gradient. I'm going to run out of room. Oh, it's pretty bad. What you should be getting though is 2 intersection points on that line. It really was a terrible line. How about we just graph it on? I know I've been really going on about this, but you know, these calculators are new for you guys. So again, y equals, I'm going to deselect that one. The hyperbola was -10 divide x. The straight line equation, I've got it on the screen, it was half x, 0.5x, then it was a +6. We had 2 points of intersection, so I'm kind of interested to see that. What does it look like? There. One of them, oh, because it's all the way at -10. Actually, that might be interesting. If I went to try and find it, I think the calculator might struggle. So first curve, second. Is it getting that first curve? Yeah. Oh, because it's off screen, it doesn't like it. All right, that'll do. That can be my first curve. That's my second curve. Now, it's this one out here. I'm wondering if it will actually find it because it's right on the -10. Let's see. No, it did. Good. -10. If you change your window, if your window is too small, I think it won't find it. So it's off screen now. So adjusting that window is sometimes important. First curve, second curve, guess. So I don't want that point of intersection. I want to see if it can find this. Oh, look, it shifts over. Fancy. Wow. Fantastic. So it probably will find it still. Yes, you little Anzac. So it seems like the calculators have improved from the old ones that I'm used to. Now the other one, of course, first curve, second curve. Make sure you're doing the guess. Can you see why they have the guess function now? Because there's 2 points of intersection. You've got to tell the calculator, right? X is minus 2, y is 5. Again, use the calculator. It is your friend. Okay. Although for something worth 4 marks, you do need to be showing some working out. You need to be saying, you need to do the rearrangement here. You need to make the statement that what was it, half x plus 6 equals minus 10 on x. And then you need to write the answer properly, even if you're doing it all with a calculator. Now, function notation, right? So what we've got here is a function. It's not very clear. It's that function. I can tell because minus 3, there it is there. Pretty steep, slope of 2, yeah, checks out. Okay, so that function is the same as this graph. Now when they say what is f of 3, really straightforward. Where you see x's, you're putting 3's. So that would be 6 minus 3 is 3, right? On the graph, it's this point here. Okay? Don't need to label it. F of 2 of x, maybe a bit confusing. Everywhere you see an x, it is now a 2x. So we got 2x minus 3. 4x minus 3, leave it alone, right? Those are not like terms, you cannot do anything with them. Domain and range, you've just got to remember domain, right? You're talking about x's, range, up and down, you're talking about y's. And you can see that with this function, right, that is specified here. Now the way to write the domain is to say that the x values lie between, what's that? That's a minus 2 and a 3. Okay, now this is an open circle, right? So it does not actually include the minus 2. I'm going to leave that as a smaller than. This is a closed circle. It does include the 3. So I can say x is smaller than or equal to 3. Now this notation here is lies between. That's how I think of it. You want to say this number's smaller than x and x is smaller than that number, or read it backwards. X is greater than, x is greater than minus 2. Yeah, it is. But I like to, whenever I see the two smaller thans and an x in the middle or a y in the middle, as I'm about to do here, I read it as lies between. The y values lie between minus 7 and 3. They include the 3. Right, so we're using the smaller than or equal to. Okay, if I had a, well, maybe just a, let's just, if you're interested, say it did that, right? What would be happening then there is I could just say the x has to be greater than minus 2. Right, I'm trying to sort of copy this picture again. So if that function doesn't stop, right, the x's can just keep going on forever, or I could have said x lies between minus 2 and positive infinity. Right. So it is possible that you'll get a function that's not, that doesn't have these upper and lower limits. It might just keep going all the way out to infinity, and that's okay. Right, you can still define the range and the domain. And I think that's actually the last question. All right, so I hope that was useful. Thank you.